The link to get these slides is the same as last week. It's just github.com/jpowerj, my GitHub name, and then DSUA111-sections. Except this week I've like organized it a little bit better so that now if you go to that URL, you'll see like there's a little like intro here where it has my email, and it has a Google Calendar link and a Zoom link for this section, right, which is section 004. So the Google Calendar link is just recurring link you can add if you use Google Calendar, and then the Zoom link is the link to open this meeting, and then also my office hours, which are 5 to 6 p.m. on Wednesdays, another like recurring Google Calendar link and a Zoom link. And I've also put down here, last week, it was a little frustrating maybe because like I had the slides set up on my end, but unless you like did a whole thing of downloading the GitHub and everything like in full, you didn't have the slides. But so I figured out this week how to export them to PDF. So now here on the like front page of the GitHub, you'll see week 1 Python, that's this week, and PDF slides. And the PDF slides are just like a PDF rendering of exactly what I have, right? So you'll be able to follow along like one for one. Cool. So yeah, hopefully everyone has that. I pasted it in the chat. Oh, great, cool. Yeah, if you look in the chat, I pasted a link to it, right? Like, you know, like 4 above the current one. And cool, so let's start the class. So yeah, this week is Python. If I do it right, it will be hopefully even shorter than last week. And yeah, I just want to, what I want to front load actually is the slides. I should have put the last slide as the first slide because the last slide here, if we go through everything, is a link to a resource called learnpython.org. And like, so full disclosure, like me and Will made these slides like a year ago. And yeah, we basically knew like Learn Python and a couple other resources, but since then, basically, we've seen that there's like a million different online resources that you can access for learning Python, right? So I just want to like put that at the beginning because it's kind of daunting that like, I don't know that me and Will's way of teaching Python is like the way that will click with your head the best, right? With your learning style and everything. So learnpython.org is one of them, but like there's tons of others. Like learnpython.org is a little bit old school in that it just kind of is like text and you just read it and you go, okay, cool. But if you want something more like interactive, there's like Code Academy, if you've heard of that. And that has like this interactive setup where like there's a little bar on the side and it says like step 1, make a variable. And then you write the Python code and it says like, great job, step 2, right? So that's more interactive, which is, I would guess, more how like normal people learn, like interactive, like you're millennials or Zoomers or something and you're used to interactive internet things. There's YouTube videos, there's a million resources. So basically all that is just to say that like, if you find yourself struggling learning Python, I just really, really want you to like internalize that, yeah, there's a million different ways to learn it and to think about like what's going on. Some people, you know, it helps them to know like what's going on under the hood. Some people it's like, oh no, I just want to sort of know the commands and like, I don't want to, it like hurts my brain to think about how they work under the hood and stuff like that. So yeah, just different types of resources. And if you find yourself struggling, just like, please, please, please don't feel dumb. Don't feel like you're doomed. Like we can find a resource for you that will work, or at least we can try like a million different kinds and see if something clicks. So just wanted to put that there. What else? Yeah, oh, and then yeah, one other thing is that like with programming, Python, but just like programming in general, it's hard to, I think it's hard, almost harder than a lot of other fields to gauge like how well you're learning it, in the sense that a lot of people, I think, they think like, oh, I have to memorize all the functions and I have to like, every line of code I write has to be perfect. And some people are like that. Like, I'll admit, there are just people who learn it like they learn like, I don't know, a Chopin on piano. Like they're just like, I'm nailing every note, I'm getting it perfect. But that's not really like me, for example. I kind of code, oh yeah, sorry, I have a cat. This is Hugo, and he'll just come into the lecture whenever he wants because he's a cat. But yeah, there's a there's like a way of programming that I kind of do, which is a lot more based on making tons of mistakes and kind of almost using the mistakes to like guide the way that you learn how to code, or the way that you figure out how to solve a particular problem, right? So like, I don't want you to think that, oh, I don't like have all these Python functions memorized or whatever. I don't want you to think that that's not like learning, like that you can't be a data scientist unless you are learning how to code in that particular kind of like, regimented, musical instrument style way. I think it's totally fine. And like, if you sat down and watched me code, yeah, you'd see that I don't have anything memorized. I'm just constantly Googling stuff and being like, oh yeah, okay, cool. That's what that's called. Okay, cool. Or I'm just like making tons of errors because I'm just kind of like writing a first draft, almost, is how I think of it. And then I just see the errors and I see, okay, all right, I have to figure out how that function works. Okay, cool. My guess was right on this one. It wasn't right on this one, right? There's just all these different ways. So yeah, just that's a preamble on like what it means to learn how to program. Why are we choosing Python, right? There's millions of, well, there's not millions, but there's probably thousands of programming languages. First two are, whatever, but the one I want you to focus on here is the third one, which is that there's a huge library of outside code you can use. Like, there's a fancy term in computer science called Turing complete, and it essentially just says that like every programming language, for all intents and purposes, unless it's like a quantum computer, actually no, even quantum computers are the same Turing complete as regular computers, but all these computers they can all do the same tasks, they can perform the same functions, right? So like, if you see people arguing about like, oh, this programming language is the best, this programming language is way better than this one, like, that's okay, it's a good activity, it keeps them off the streets, it gives them something to do, but there's a mathematical sense in which actually all the programming languages are all capable of doing everything, right? Like every programming language can simulate every other one. That's just, you can look up Turing complete if you want to see how that works and what that means really. But the point being, like, choosing a programming language is more about just like which ones are like doing those things that you want to do is easier, right? So for different types of tasks that you want to do, right? If you're a data scientist, Python is really great because of this huge library of outside code, right? People over the past like 20 years since Python came out have just written tons and tons and tons of like add-ons to the language that allow you to just, you don't have to reinvent the wheel, right? You don't have to like rewrite code to find the standard deviation of a data set or something. There's a package that someone's already written, well, a library package. There's a additional set of code that someone's written that you can install into Python and just like skip past all these like details that you don't have to worry about because someone has already worried about them and written code for, right? So that's, to me, like the #1 selling point of Python. Like, I'll say if you go into like a social science program or job, whatever, there's another popular language for data science called R, Some of you might have heard of that, but I'm not gonna lie, like so in my program, everyone uses R, but I still use Python stubbornly because just like on the sheer basis that when I have like a task I want to do and I'm looking for a library like where someone has coded some things that will help me do it, personally, I just always seem to find like the Python one. Like I can, if you wanted, I could rattle off things that like there's no package that does it in R, but there is one in Python and it's something that I need. So I just use Python for that, right? But maybe you find yourself in a field like, I don't know, biomedical informatics or something where like for some reason people have written a ton of R packages for it, then yeah, use R. But in this class, for like data science and then machine learning, like it says here, yeah, it's pretty much the default language. Like machine learning is like almost becoming an antiquated term at this point because like neural nets have kind of won all of the machine learning tasks. If you've heard that buzzword, it's like a neural network is like a method for machine learning, but it turns out like it just beats all the other methods on almost everything. So now you know, when it says machine learning here, in maybe 5 years it'll say neural nets, but the reason I say that is because like there's like 99.9% of neural net software, their software applications are just all done in these two packages. One is called PyTorch and one is called TensorFlow, and both of those are written in Python, right? So pretty much like the future of machine learning, as far as we can tell right now, just like is Python, right? So if machine learning, neural nets, AI, if these things like appeal to you, you know, Python is like literally, I personally have never like seen anyone do neural networks, at least. I've seen machine learning maybe, but neural networks specifically, never seen anything other than Python. Cool, but yeah, there's also like web programming. I personally like from the lab that I work in, we have all these little like web apps and I just write them all in Python as well. There's a library that someone's written called Flask, which is software that you can like add on to Python and make it so you can code servers and server code in Python. So yeah, that's the selling point for me. It's not like the language, like I don't really care about the syntax. Our syntax is just as good in my view, but it's the libraries, right? So that's why Python. And now Jupyter, like if you pay attention to one thing in this section, hopefully it's this, because in earlier semesters, I didn't drive this point home enough and it led to a lot of confusion as things got more and more like complicated. So I just want to like, I want you to have this mental image that Python is a program that like sits on your computer, right? Once you install it, it's sitting on your computer. And the way that Python works is like, it just sits there and waits for you to send it Python code. And then it produces an output for that code. Like that's pretty much it. I always can't remember if I'm doing this right. Can people see this little like matrixy looking box here that says command prompt?
Is there any way to make it bigger?
What did you say? Sorry.
Is there any way to make it bigger?
Oh, make it bigger. Yeah. Hopefully, yes. It is gonna look weird though, but yes. Hold on. Font. 20. Is that slightly better? Should I try one more bigger?
Better. It's fine with me.
Okay, yeah, I mean, I'm just showing this because like, you'll see like Python as just a program that sits on your computer. It's pretty gross looking, right? It's just this like text program and you type, you know, like 1 + 1 and you get 2, or you type print hello and you get hello, right? But hopefully you already noticed one thing here that is different from Jupyter, which is that like I can't go back and edit my code that I've written and executed before, right? It's like, oh no, I didn't want to add 1 + 1. I wanted to add like 5 + 1 or something, right? But in Python, just as like the base level, like most core program that I'm running right here, yeah, you can't like really go back. You have to just like rewrite it like 5 plus 1. Right, and that's where Jupyter comes in, because Jupyter is like a program that sits on top of Python, right? So we actually saw last week, right, that every Jupyter notebook is kind of like sitting on top of a Python installation, right? We had to worry about that because I had to rant about how we don't want to use the basic Python. It's called a kernel. We don't want to use the basic Python kernel. We want to use the DSUA111 specific Python kernel. So that's like what's happening, right? Is like this, when you hear Python kernel, think of like this, that it's this kind of not that user-friendly textual like command prompt or / terminal program, whereas Jupyter is like a little more visual. And the nice thing about Jupyter, right, is that you can go back and edit code that you wrote before and like rerun it, right? So I'm just going into my little Jupyter notebook here, right? If I did like 1 plus 1, I'm not like, it's not like here where I'm stuck and I have to redo everything. I can go back and I can say actually 1 plus 5, right? And so that's kind of the beauty of Jupyter, is it's kind of a layer on top of Python that, all it does, like, if you think about it, it's not like a smart program. All it does is it takes the little code cells, right? These little boxes of code that we have here. And when you press Control Enter or Command Enter, it just takes it, right? And it like tosses it into the Python program running underneath it. And then it gets the output, right? It says, okay, what pops out like here, 6, right? And then it goes back and it displays that, right? So it's just a wrapper around Python, but very helpful in the sense that you can like try different things, right? I know it seems kind of a dumb example, like changing 1 plus 1 to 1 plus 5, but you know, imagine like you're trying to, like you're trying to analyze a data set and you like typed the name of a variable wrong. You don't have to like go back and rewrite your entire analysis of the data set, right? You just go back, you edit the name of the variable that you typed in and you rerun it, right? So that's kind of what's happening. That's why we have these two different things, right? So I don't want you to think that Jupyter is like synonymous with Python, right? Because Python came first, right? Jupyter came like 10 years after Python. But just think of it as like a nice little interface into Python so that you can like edit, go back, instantly like see the output, change things, see how that changes the output. It's just like a more user-friendly like extension of Python. So cool. This you don't need to worry about that. It's the definition. Me and Will made these slides together, and I'm skipping past some slides that I'm like, you can look at them on your own time. But this one's important because you'll start to feel very weird when you're using these programming languages, because you're in like the 21st century, and we have like AI robots, and we can like go to the moon, and we can do all this like intensely fancy stuff, right? Facial recognition, whatever. But and so you'll think that like programming languages, wow, they must be super like smart and they'll like know what I'm saying, but actually they just won't, because programming languages are actually designed to err on the side of like super precision of what you're asking it to do, to the point that if there's any confusion whatsoever about what you're trying to do, it will just give you an error, right? Like the errors are there, not because it would be impossible for a programming language to figure out what you're doing, right? Like you could imagine an AI programming language that tries to figure out what you're doing, but more because like just it's specifically made for like maximal precision. So like the first example you'll probably run into, right, is if you write a variable, right? Say you make a variable called like my number, right? And so you say like my number equals 5, but you accidentally have a typo in the word number, right? So you put like my NUMBAR instead of ER, then like later on in your program, you try to access it. You try to say, okay, cool. Python, what was that? What number was stored in the variable called my number? And it'll just go like, I don't know what you're talking about. There's no variable called my number, right? And that's because like you typed it. But here, I'll just show you. And then yammering. Like if you say my number equals 5, right? And then you're doing a bunch of other stuff you kind of forgot, right? Great. And then you say like, cool, what's my number again? It'll just be like, I don't know what you're saying, right? Like my number is not defined. Even though to us, it's like, we're as like humans, we can be like, oh, I see. No, you meant just show this, right? That's what the person meant. But to a computer, it's like very literal, right? It's looking for exact matches. And if it doesn't find anything in its memory that like exactly matches what you type, then it's just gonna give an error, right? So again, computers at like a macro level, very smart, they have AI and everything, but at the micro level of like programming them, they're not smart. You have to get it just right. And yeah, it's a whole thing, but it's just because like they're made to err on the side of precision. So cool. Just be careful. Like if you see an error, that might not mean you did something dumb. That might just mean like the computer is dumb and you have to be like more specific about what you want, if that makes sense. So I just want you to keep that in mind. Cool. So this slide is like very important. This is the meat of the whole lecture in a sense, because it's your first like step into Python, but you'll already see a bunch of quirks of this programming language if you're just used to language as like human spoken language, right? Like English. So what we want to do is we'll create a variable and we want to store the value 5 inside of that variable, right? So we make this line right here is telling Python that it's okay. All right, ready? So quirk 1 of programming languages is that you kind of, when you have a equal sign, a single equal sign in a statement, already you get a weird thing because these statements are read from right to left by Python. And so what this is saying is it's saying take the number 5 and then the equal sign is not how we use it in ordinary English. Like in ordinary English, if we say 3 squared equals 9, that's kind of a question, right? Like 3 squared equals 9, and that's like true or false, like question mark. 3 squared equals 9, question mark. And then the answer is true, right? Yes, 3 squared does equal 9. Whereas if I said 3 squared equals 10, that's false, right? So like it's kind of a question when we say it in English. Or it's like an assertion that something is true, but either way, it's like a thing that evaluates to true or false, right? But in Python, the single equal sign is not that at all. In Python, the single equal sign is a command. It's not a question. It's a command telling Python, take the thing on the right-hand side of the equal sign and store it into the variable on the left-hand side of the equal sign, right? So yeah, it's just not, it's very unfortunate like syntax actually. Like if anyone's familiar with R, they actually kind of fixed this in that in R, the assignment is an arrow. Like it's literally an arrow pointing right to left, right? So like, let me just show you like and I can make this a little bigger. But in R, you would say a arrow 5, right? So I'm just like saying like that's one thing that R does right, I think, is it's saying instead of a single equals, which confuses humans because that's not how we use equals, they use an arrow saying take 5 and put it in the variable a. But alas, for Python, that is the single equal sign, right? So the single equal sign is an assignment operator. Whereas you'll see here, right, there's 2 equal signs. And the 2 equal signs, the double equal signs, is the one that corresponds with how we would use the term equals in day-to-day English, right? Which is like the question, like, so I just stored the number 5 into the box A. And now I'm saying, hey, Python, can you check what's in the box A and is it 6, right? So you're like asking it a question, right? Is the value stored in the box variable A 6? And the answer is false, right? Because it's not, it's 5. But in this case, we say, okay, is the value stored in A 5? That'll give true, right? So if you can almost like make a mental note of this slide, I think it will just help a ton, right? Because things can get really messy if you don't keep these apart, right? Like you'll think you're asking Python like, oh, is A equal to 5? But you'll accidentally write this and Python will go, okay, I'll just put 5 into A, right? So instead of asking a question, it's actually like making it true, right? It's forcing A to be 5 because it's assignment, right? So yeah, then this last thing is just saying this is your first built-in Python function. I mean, yeah, built-in Python function that you're learning called print, right? And print just says, hey, Python, like I'm gonna like provide a name for you, in this case, A, and I want you to go and find what its value is and just display it on the screen, right? So that's how this works. It goes into memory. It looks for a variable that you've created called A, and if one exists, then it finds its value and prints it to the screen, right? This is another like case where you have to be careful because, for example, yeah, if you did A equals 5, but then you said print like A, right? It's gonna get an error, even though this one's A and this one's also pronounced A, technically. It's not, it has to be like an exact match, right? It has to be this for it to work. So yeah, just, I know it seems silly, but like the more you can remember that, like if you get an error, the first thing to think maybe is, oh, did I make a typo? That can like really help later on when you're writing a bunch of code and there's a lot of complexities mixed in, right? Cool. So yeah, hopefully this makes a little bit of sense that single equals and double equals, you want to be like very careful about keeping apart. Cool. And that's, yeah, this is just what I just said. Great. So I talked about this last week as well, so I won't spend that much time on it, but if you just write a single line of code, right, just one line in your code cell in Jupyter, it will just produce the output and it's just the result of that one line, right? So everything here is kind of what you would expect, right? Here, we're saying, hey, Python, I want you to make a new box in memory called C, a new variable called C. I want you to store the value 47 in it. This is saying, make a box called D and put 5 in it. And then this is saying, take the value that I put in C, take the value that I put in D, and add them, right? And it'll produce the output. But what you have to be careful about, right, is that this nice little like one-to-one mapping between input and output only works if there's one line of code in your cell, right? So again, I did this last week, but just to reiterate, like if I am doing more than one thing in a cell, right here, I'm doing like 3 additions. By default, Jupyter is actually only going to print the result of the last operation, right? So that's why like the print function, right? Python's built-in print function becomes your friend because usually, not always, but usually like you want to see what's happening in like all the lines, right? Or at least more than just the last one. Like if you have a cell with like 50 lines in it, you probably want to like monitor what's happening, right? Not just see what happens at the very end. And so that's why you would explicitly put like print around it. Functions, yeah, and now it will print all 3, the result of all 3 computations. And Yeah, the syntax for functions might seem a little weird at first, unless like you think you remember in like high school, like pre-calculus or calculus, you know, like f of x. That's kind of the syntax that they were going for with this, which is like you have the name of the function, right? And then you have parentheses, and everything inside the parentheses is called like the argument or the arguments, if there's more than one, to the function. Cool. So just like you have single variable function f of x, you have multivariable function f of x comma y. Similar, like let me think of a, well, like, yeah, technically print can take multiple things, right? You could say 5, 10, 15, and it'll just print them separated by a space, right? So this is like the single argument version of print, and this is the multiple argument version of print, right? I was just showing you that to show you like this is the syntax that you'll see for functions, right? Name, open parentheses, list of the arguments, close parentheses. Cool, cool. All right. So, all right, we've already kind of been through this stuff, which is that it can do addition. Unlike the equal sign madness, plus sign and the minus sign act as you would expect them to mathematically, right? So the plus sign, that's just like the plus sign that you remember from math, and same with the minus sign, right? Where it gets a little tricky is multiplication and division, because division is this like forward slash, which, you know, makes some sense. Like you might have done that when writing fractions or something, like 1/4 is 1/4. That's hopefully fine, like that kind of matches what you're used to from math, but the multiplication can trip people up, because multiplication is this asterisk, right? It's not like the letter X, you know, like if you're just like doing math, like written, right? If you're just writing a math homework, you might think like, oh, 12 times 4, that's like that, right? 12x4. Python is not gonna like that. It's not gonna know what you're talking about, because although numbers are interpreted the normal way in Python, letters, it's always gonna think that you're referring to a variable, right? So here it's gonna think you're referring to a variable named X. And it's gonna be like, I don't know what you want me to do with these. You put 12 and then you put a variable name and then you put 4, right? It doesn't view this as like an operator, right? So just keep that in mind, that yeah, addition, subtraction, and division so far hopefully kind of work the way you would expect, but multiplication, it's the asterisk. Cool. And then it gets even weirder with exponentiation, to be honest, because this is weird even for like programming languages, which is that it's just 2 stars instead of 1, right? So multiplication is 1 star, exponentiation is 2. One way you can remember this is like, you know, exponentiation is just repeated multiplication, right? Like 2 to the 4th power is 2 times 2 times 2 times 2, right? So that's how I remember it. It's just like, it's, you know, it's like exponentiation is like double multiplication. It's repeated multiplication, right? Just try to remember, because check this out, this can get really sketchy, which is you might think like, oh, the caret, right? Like this little caret symbol is how I do power, right? Like in a lot of programming languages, in fact, most that I know, that's how you would do exponentiation. Like this is how you do 12 to the 4th, but well, let me do something simpler, 2 to the 4th, right? But is 2 to the 4th 6? No, it's badness, right? It's 2 stars, or whoops, 2 to the 4th, 16, right? So in case you ever get lost or you forget, do a sanity check, right? Make some new code cells in your Jupyter notebook and just like do what I just did, right? And be like, as a reminder to yourself that this is not exponentiation, it's this. I don't know if anyone knows what this is, but it's a mathematical operator you should not ever have to use, basically. it's bitwise and, which means it takes the 0, 1 representation of the two numbers, and then it takes the and of each column. Like, you're not gonna, pretty much 100% of the time, that's not what you want to do, right? You usually want to do something a lot more normal, unless you're like coding a processor or something. I don't know. Yeah, this is bad. It should raise a red flag in your brain when you see a caret symbol in Python, because it doesn't do exponentiation like you might think. Cool. So back to the slides. Great. What this last line is showing is a little bit important, which is like, so here what we're doing actually is we're showing that we could do exponentiation not just with numbers themselves, right, but also with the values that are stored in variables. So I'll just show you way back here, we made C hold the value 47, right? And now going forward, we can take C and we can square it. This is saying C to the power of 2, right? And again, when we see these single equal sign statements, we read them right to left. So we said it first computes C squared, so it figures out, it says, okay, I'm gonna look in memory, I'm gonna see what's stored in C, I'm gonna square it, and then it moves right to left, right? So then it says, okay, and now I'm gonna store it in new answer. So I'm going to make a new variable, I'm gonna make a new box in memory called new answer, right? But if you look at it like this, you'll see actually it doesn't output anything, which can be really frustrating, right? Because you're kind of like, wait, no, but I wanna see what C squared is, right? Like, yeah, I want to store it in a variable because I might want to use it later, but I also want to see what it is, right? And that can be kind of frustrating when you're first learning Jupyter, is that it doesn't, when you do these assignment statements, it doesn't like output anything, right? It just says, okay, cool, I did the assignment and I'm done. If you want to actually print the result of it, you have to like explicitly use the print function, right? Or just make a new cell and just put like the variable, right? And then it'll show you the value. But just keep that in mind, like, yeah, you have to do some additional work after the assignment statement if you want to see like what the result was, right? So cool. Yeah, this is similar, like this is maps onto what you know from math, which is that square roots are just exponents, but with fractions. So like the square root is, yeah, the square root of 16 is the same as 16 to the 1/2 power. And so if you see square roots or cube roots and stuff like that, Python doesn't have a built-in like syntax for it. So you have to convert it into this exponentiation format, right? But it will like correctly compute the square root, right? 16 to the power of 1/2 is 4.0. And another thing you can notice from this is that it does the order of operations correctly, right? So I'm actually always like curious if PEMDAS is a thing, like a global thing or not, but that's how I learned like order of operations. It's on the next slide that, yeah, Python knows PEMDAS, which is parentheses, exponentiation, multiplication, division, addition, and subtraction, PEMDAS, right? Meaning, unless you give Python like very specific guidance on what order it should do the operations in, it's going to assume that's the order you want, right? The parenthetical statements get evaluated first, then exponents, multiplication, division, addition, subtraction. Cool. So same thing you learned in math. And then, yeah, this is similar to what we did before. I'm trying to go a little fast because a lot of these later slides are just more practice on the earlier ones, and you can practice it like over the weekend or on your own time. So, because I want to get to, yeah, this is the Pythagorean theorem, just showing how you can use like variables and the math operators in Python to make a little Pythagorean theorem calculator, right? If you didn't learn it in school, it's like, what is it? It's like the Pythagorean theorem says that if it's a right triangle, and I was a math major, I really was, but I forget everything because I'm old. But it's like if you have a right triangle, you take one side, you take the bottom length squared, and then the side length squared, and that is equal to the hypotenuse length squared, right? So yeah, there's a Wikipedia link here that I put in, but yeah, it's just showing like you can make a little program inside your Jupyter cell that computes Pythagorean triples, right? So you know that the length of one side is 6, the length of the bottom is 6, the length of the side is 8, and so compute the length of the hypotenuse, right? We use our Python skills of we know how to do exponentiation, and we know how to take square roots. We know how to like take a computation and assign it into a variable, in this case C, and then we know how to print its value, right? Cool. Yeah, this is, whoops. This is like the second most important thing in the lecture. The most important thing was my little spiel about how Jupyter is built on top of Python. And they're not synonymous. But this is the second biggest deal, is that you might like, I feel like it's hard to, it might be particularly hard to like teach students in schools about, oh wait, is there a chat? Sorry. Oh, okay. So let me, yeah, wow. There are 2 questions in the chat that I didn't address. I'm sorry about that. Yeah, no, I was explaining two, and then the caret, and then the 4. It's called the bitwise and operator. You can Google that if you want. Here, bitwise and it literally, like, you know how in computers numbers are represented as sequences of zeros and ones. And so what 2 to the power, sorry, what 2 caret 4 will do in Python is it will take 2, which in binary is 1 0, base 2, 1 0, and then it will take 4, which in binary is 1 0 0, right, base 2, and then it will take the and, it will stack those 2, and it will take the and so it's 0 0 0 0. Yeah, it'll be it's not an operation that you need to ever do, really. I've like done like a bachelor's and master's and PhD in computer science and never had to use that, so I wouldn't worry about it. But it's bitwise and. Can we use idle for homework? I don't know. I don't know what that is. If Sky, if you want to tell me what that is, I've never heard of idle. I don't know. Idle. Python. Okay. Oh, I see. Yeah. All right. Well, so Jupyter is okay. Thanks. Yeah. Thank you both. Thank you, Evie and Sky, because it's sorry, it's a good question. Jupyter is an IDE. Yeah, Jupyter is the IDE that we're using in this class, right? So IDE stands for Integrated Development Environment, and it's just sort of like the program that you use to code Python or whatever language you're using, right? So like the dumbest, most basic IDE would be this gross looking like thing here, right? This is just like the base Python quote unquote IDE. Though you wouldn't even call it an IDE, really. Like you would call it an IDE is usually like a separate thing built on top of it, right? So yeah, Jupyter is the IDE that we're using in this class. I've never used, I guess I kind of like have a notion in my head of what IDLE is, but yeah, I've just never used it, and we're now using it in this class. You can use it, but yeah, it's gonna be kind of hard because I don't think I don't know. I've never seen anyone who uses it, so I don't really know like how well people would be able to like help if something goes wrong with it or something. You know what I mean? I would just use Jupyter because we have like the Jupyter server set up for everyone. But yeah, you're not like it's not like you're gonna get points off if you don't use it. But yeah, Jupyter is the IDE we're using in this class. Cool. Thanks. Sorry for not seeing that until now. Cool. So yeah, great. So, but errors, yeah, they're not a big deal. I was yeah, saying that like it's really hard to teach students programming in the sense that like you're used to like, students are used to like, oh, I did something wrong, like I did something bad if I get a error or mistake or I get a point off or whatever. But in programming, I really, 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 truly am not just saying this to like make you feel better or something. I truly like, the way that I program is I just get like a ton of errors and I slowly like fix them, and like that's how I code. Like, you know, for like creative writing, like for writers, they do a thing, forget what it's called, but it's like where you just sit and like write whatever comes to your mind for 10 minutes. Like that's kind of how I program. I just kind of write the gist of what I want it to do. You know, like if I'm writing some big program, I'll just write like, all right, first I want to do something like this, and then I want it to do this, and then I want it to save the file here, and then I want, right? And I'm kind of just going, and then I do like a second sweep, and that's when I like say, okay, yeah, that wasn't the name, that wasn't the right function for that, or like I spelled that library wrong, or yeah, I didn't use that function correctly, but yeah, that's how just like how I code. So I just like really want to reiterate that it's not like, yeah, it's not like learning like a piano, like it's not like learning a Chopin piece on piano where you're like, oh, I'm gonna get every single note perfect, right? I think of it more like, yeah, you're just kind of trying to get down on paper like what you're trying to do, and then to me, I just slowly like get it into a working state, slowly, like iteratively. And so yeah, the point of this slide is that like errors are not like the end of the world. Here's an example of an error. I actually kind of hate that Python makes the font red, right? Because red is, again, that thing from school where like you get a big red X on your paper and you're sad and you get yelled at or whatever. But like errors in Python are just not like that. You can actually use them as guides to kind of like make sure that what you're doing is actually like what you want to do, right? So I say that in the sense that like some Python errors are not even errors as such, meaning like some Python errors, it's just Python almost saying like, hey, I don't know, do you really want to do this? And sometimes you can just say like, yeah, leave me alone, just do it, run this, right? Meaning like sometimes the errors are literally not even errors and then per se, like they're there to like to like warn you sometimes. Sometimes the errors are like real errors. Like this one, you know, if we just type C_hello, the problem is that nowhere before it in this file, in these slides, or if you're looking at the Python notebook, we haven't defined anything called C_hello, right? So yeah, it's going to give you this name error and it's going to say it's not defined, right? And this goes back to what I was saying about how Python's super like precise. So like maybe, you know, you might see this and maybe you're like, oh, that's because it was B hello, not C hello, right? Or maybe it was like SEE_hello, right? Yeah, just like don't freak out if you get an error. Just use the error as like a guide, I would say, to like go and fix it. Like if we had more time, I would literally, I could just like open my like dissertation work Jupyter notebooks and show you it's just all errors. I just like, my life is just wading through errors. I literally like 10% of my time is writing the lines of code and then 90% is like fixing it, right? So just please don't think that you're like a bad coder or something, or you're not like doing well because you're getting errors. They're there to kind of guide you towards the right way to execute a particular function. Cool. Yeah, you can look at this. This is just saying like the error doesn't crash your computer or anything, right? Older programming languages like C, like if you ever end up in your life coding like C, then you might start to get scared of errors, because in C there's a type of error called a segmentation fault, which crashes your entire computer and like you have to start everything over. So that's bad, right? But Python and Java both, just for like historical fun fact, like we're kind of built to eliminate that, meaning you have to try really hard to crash a computer using Python. It's almost impossible. You can do it, but not in C, like half the errors crash the computer. In Python, there's like, you have to do something really messed up to crash it. So the point being, like, you're not gonna crash anything. You're not gonna mess anything up. The NYU servers are gonna be fine. All the variables that you made up until the error are gonna be there. It's not gonna destroy anything, right? So yeah, just make mistakes and experiment. Python will not get mad. You can make a million errors, get it right on the million and first try, and it'll just say, all right, cool, next, right? It's not, no one's judging you. Cool. And that's the link I showed at the beginning, learnpython.org. But like I said in the beginning also, there are millions of like resources at this point for learning Python, for learning like programming in general. Like if there's something about the logic of like, oh, I can think of something that I want to do in my head, but I don't know how to like transform that or translate that into computer code. Even that sort of like more abstract mental process, like there's, you know, online interactive resources to help you be like, oh, how would you solve this in like write how you'd solve it in English, and then it'll like help you like translate it from human English writing into like computer code, right? So every sort of thing that you might trip up on, I just hope that you know that there's most likely a resource out there, and you can email me to and I'll hunt for it. So great. Are there any questions? I just realized the last thing, which is I forgot to teach you how to install Jupyter on your local computers, which I said I'd do last week, but it's fine because that's super quick, super quick, which is just search Jupyter lab install, right? And you will get this link that I will paste in the chat. And nice. Okay. And then you will look that up, and the one I want you to focus on, just for the sake of this class, like you'll see there's all these different ways of installing Jupyter. So you don't have to worry about the NYU server. You can, even if you don't have internet, this will let you write code and stuff, and it'll be the same interface. I like this pip one because pip actually comes with Python. Pip stands for Python Installation Program. And so what this is just saying is like, if you have Python on your computer, Macs come with Python. Windows, I don't think necessarily come with Python, but a lot of them, like other programs, will install Python on it. And if you are having trouble, email me, please. I feel bad that I didn't get to this until now. Yeah, Python installer program space install space Jupyter Lab, all one word, right? And that's it. It will just do everything for you. And it will say like installed, good job. If it doesn't, email me. It should say installed, and then literally in the next line in your terminal, oh, I should have said, yeah, you type this into the terminal on Mac, or on Windows, it's the command prompt, and you can look up how to open that. Windows, it's you press Windows key and type CMD and press enter. That's it. That'll open up the window that looks like this, and you type pip install Jupyter Lab, right, and it says installed. Last step, you write Jupyter space lab. It's this right here. That's it. Just Jupyter, and then a space, and then lab. And it will literally like pop up, right? It'll pop up, and you'll see it's an interface that looks exactly like the NYU, rcnyu.org interface. And I recommend coding on that because you don't have to worry about idleness and crashing and everything, losing any of your work. Like you can turn off your computer, come back a day later, and it'll still be there, right? So that's what I do. I got sick of losing my work on the rcnyu.org, but still use rcnyu.org to submit. Just I would work on yeah, you get it. Any questions? Sorry, I went a little over because of this, but yeah. Have a great weekend in that case, and I'll see you next week. Thanks.
Jacob, I have a quick question.
Yep.
So I typed the command into terminal, but I get this thing that's called to update your account to use ZSH. Please run something. Can I share my screen with you?
Yeah, let me try that. One sec. Yeah.
Okay.
Hold on. Sorry. I'm stopping the recording real quick just because this is, yeah.
Yeah.
Cool. Okay.
Can I try?
Yeah, I think I